Yeah. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yeah, it's clear and screen is visible.
Yes. So what is big, so as part of today's demo, I'll be covering the following topics. Okay, before that, myself, I'm Vijay. I hold 20 plus years of experience, which includes nearly 8 years of experience in Hadoop and Spark environment. So as part of today's demo, I'll be covering the following topics. What is big data? Why Hadoop? Drawbacks with the current databases. Drawbacks with the current databases, right? Yes. Hadoop advantages. Hadoop job market. Hadoop and PySpark job market. So this is what I'll be discussing as part of today's demo, right? So what is big data? Why Hadoop drawbacks with the current databases? Hadoop advantages? Hadoop and PySpark job market. Big data, the name itself saying that huge volumes of data. Currently, the data is getting stored. What the data storage units like KBs of data, MBs, GBs, gigabytes, terabytes, petabytes. Beyond that, we have got petabytes, exabytes, zettabytes, petabytes, sotabytes, so on, right? Yes. You should have seen KBs of data, MBs of data, GBs, or even TBs. But beyond that, we have got petabytes of data is getting generated today, right? Petabytes of data is getting generated. Examples of petabyte of data generation. Examples of petabytes of data generation, right? 1 petabyte. 1 petabyte equal to 1024, right? 1024, yes. TBs. Already 1 TB is a large storage unit. 1 petabyte equal to 1024 TBs. Okay. So example, if you take any banking sector like SBI, right? If you talk example of an SBI bank or any other bank, right? So within the city, you see hundreds of branches for it. Within the entire state, thousands of branches. Within the entire country, right? Lakhs of branches. Again, in each branch, millions of customer, each customer making multiple transactions, right? Each customer making multiple transactions per hour, per day, per week, and per month. Yes, lot of transactions, right? Lot of transactions, huge millions of branches, lakhs of branches in each branch. Again, millions of customer making multiple transactions. Huge data is getting generated, right? Forget about this bank. You are aware about the social media like Facebook, right? Facebook. Millions and trillions of users, millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? What should be the storage capacity? What should be the storage capacity, right? To store all the videos in the post. Not only Facebook. Today, if we talk about any application, Today, if we talk about any application generating huge data, right? 1 minute transaction. If I talk about 1 minute transaction, right? Let's talk about the Facebook posts, Twitter tweets, and Google queries. Everyone they are querying in the Google, right? Google queries. And YouTube videos upload, right? YouTube videos upload. And here, email messages, millions and trillions of people, right? Storing that messages, right? What should be the storage capacity to handle all these messages? Just now I was talking about the bank transactions, telecom transactions, e-commerce transactions like Flipkart or Amazon, right? E-commerce transactions. Everywhere we see like huge data is getting generated, right? Everywhere we see huge data getting generated. Yes. So to handle this huge data, or to store this data. So currently we have got a databases. Currently we have got databases, right? Talk about the databases like, yes, databases like Oracle, MySQL, DB2, SQL Server, right? Oracle, MySQL, DB2. These all are used for OLTP, online transactional processing, OLTP, right? They're used for OLTP processing. That is day-to-day operations. But we have got some specialized databases, right? Specialized databases used for data warehouse purposes. Specialized databases used for data warehouse, right? Like if you heard about like Teradata, Netija, Vertica, Teradata, Netija, Vertica, all this they are used for data warehouse purpose, right? It's if you talk about these databases or specialized databases, right? They can handle data up to some extent, but beyond that, they cannot handle, right? So this is used for data warehouse purpose. So as a solution to all the storage level problems and processing level problems, we have got a framework called Hadoop. Before I go with the Hadoop services, right, you need to know something about this. How this data is getting generated, what are the sources of the data, what are the different categories of data, right? Assume this is your data which got generated from the last 50 years. This is the data in the entire current real world from 1974 to 2024. If we talk about the last 10 years data from 2014 to 2024, the last 10 years of data compared with the previous 40 years, only 20%, only 20% of the data, and here is the 80%. 80% of the data what we see has been generated from the last 10 years. Only 20% we see in the previous 40 years it has got generated. Why huge data generation, especially from the last 10 years? Because of usage of technology, because of usage of smartphones, because of usage of internet, right? Huge data is getting generated from the last 10 years. We go in 1990s, right? They have got floppy disk series, MBs of data, right? But now we are handling like petabytes of data. So what are the main sources from where this data is getting generated? Main sources, right? Mainly three sources, right? Mainly three sources of data. Three sources of data. Social data, machine data, transactional data. Social data means data which got generated from social websites like Facebook, Twitter, all this such kind of data, we call it like social data. Machine data which got generated from the by reading or scanning the barcodes, chips, RFID, right? Transactional data like day-to-day transactions, transactional data like day-to-day transactions like telecom transactions, bank transactions. And mainly this data is going to occupy three formats, three types of data. Structured data, yes. Structured data, semi-structured, and unstructured. Semi-structured are like database tables, Excel files. Semi-structured, which is not totally structured, which is not totally unstructured, right? Like XML files, JSON files. Unstructured, like chart messages, articles, images, videos. All this comes as unstructured, right? So the so here if you see, today whatever data is getting generated, mostly occupying this unstructured format. Databases also can handle only structured data. They cannot handle unstructured data. The biggest challenge today, like handling this unstructured, storing and processing this unstructured data. So as data is increasing enormously, we need to have some proper storage and processing systems, right? So as a problem to all these storage level problems and processing levels, right? So we have got a framework called Hadoop. Hadoop mainly providing two things: storage and processing. Storage and processing, unlimited data storage. That too, unlimited data storage is possible, and processing. Any technology either performs storage or processing. For example, if you talk about C or C++ or Java, .NET, all these are meant for processing. We talk about like Oracle, MySQL, DB2, all these are meant for storage, right? Any technology meant either for storage or for processing. But Hadoop is meant for both storing and processing. Hadoop is meant for both storing and processing. And for storing, does Hadoop use any database for storing its data? For storing, right? Does Hadoop use any database? Means no. It has got a special kind of file system called as Hadoop distributed file system. It has got Hadoop distributed file system. And for processing, it has got an execution model called as MapReduce. Currently, we are going with Spark. So Hadoop doesn't use any technology, right? It is going with a parallel execution model, right? MapReduce on Spark. For storage, HDFS. So, yes. So Hadoop is meant for batch processing. Hadoop is meant for batch applications. It is meant for batch applications, right? Hadoop is not for online applications. Hadoop is not for online batch applications means user non-interactive applications. So you need to clearly understand, right? For what purpose? Okay. Hadoop is meant for batch applications. So if you take the huge data generation, big data, if you take as a problem, you can take Hadoop as the solution. Hadoop as the solution, right? If we take a big data as a concept, you will take Hadoop as the implementation. Okay, fine. So why databases are unable to store, why databases can't store Hadoop's data? Why databases are not able to store this Hadoop data, right? So just observe. Okay, drawbacks with the current databases. Drawbacks with the current databases, right? Yes. First thing is very less storage. Most of the databases, very less storage. In GBs or in TBs. In most of the databases, no parallel processing, no parallel processing, no parallel processing in most of the databases. And if volume increases, speed decreases, right? In databases, if volume increases, speed decreases. See some example, right? Select total amount. Select total amount, right? Yes. I want total amount from sales one. It has got 10 records. It has got 10 records. Select total amount. Select total amount, right? From sales to. Select total amount from sales to. Sales to. This table has got like 1 lakh records. Select total amount. Select total amount, right? Yes. From sales 3. Which has got 1 crore records. Which has got 1 crore records. Total amount from sales 1. Total amount from sales 2. Total amount from sales 3. 1 crore records. Which query is going to execute faster among these 3, right? Yes, try to respond. Which query is going to
First one.
the first
That
query,
is
because total amount of 10 records as compared with the total amount of 1 lakh or total amount of 1 crore. So query to query as volume increasing, speed decreasing, right? Total, okay. The first query executes faster, next second, next third one, right? So volume increasing, speed decreasing, and even if complexity, right? If complexity increases, speed decreases. If complexity increases, speed decreases. For example, I'm taking this. Select total amount from sales 1. Total amount from sales 1, right? Yes. Select average amount. This time I'm taking average amount from sales 1. Same table. Select the standard deviation of amount, right? Right, from sales 1. Total amount from sales 1, average amount from sales 1, standard deviation of amount from sales 1. Which query is going to execute faster here? Which query is going to execute faster?
again first
Again,
one.
the first query, right? Again, the first query, because second, this average amount is a two-step process. First sum to be calculated, next average to be calculated as compared to the first query. The second is going to take more time. See, the third query is standard deviation of amount, lot of internal processing required as compared to the other queries, right? So query to query complexity increasing, speed decreasing, right? Yes. Next. The major drawback with the databases can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data, right? Yes. Databases can handle only structured data. They cannot handle unstructured or semi-structured. So one example, right? Databases can handle only structured data. For example, observe this. If you want to take reviews for a particular movie, for example, reviews. Yes, reviews, right? User and review. User 1, user 2, user 3. In this way, 100 users giving the feedback. User 1 saying if the movie is good, saying 1, if the movie is bad, saying 0, if the movie is good. In the form of ones and zeros, they are giving the feedback in the form of ones and zeros, right? Can you write an SQL query to count the number of goods and bads? Can you write an SQL query to count the number of zeros and ones? To count the number of zeros and ones, yes, right? Single grouping and single aggregation. Select review wise. Review wise, what you want? Count. From which table? Reviews table. From reviews table. Group by operations. Group by a review. Output is right. All the ones, right? You group it ones and zeros. 90 people saying the movie good, 10 people saying the movie bad. 90 people saying movie good, 10 people saying the movie bad, right? So for this kind, okay. But generally, users won't give reviews in the form of ones and zeros, right? If they're giving in their own text format. First person saying movie is good. Second person saying movie is bad. Movie is not good. Okay. Third person in their own text format, they are giving reviews in their own text format, right? They're giving okay in their own text format. Can you write an SQL query to count the number of goods and not goods here? Previously ones and zeros, how many ones, how many zeros you got? But here, can you count the number of goods and not goods? Even by using a keyword count, even by using keyword count of goods, if you are trying to do, it gives wrong computation even because not good has got good in it. So you cannot handle this kind of data, right? Databases can handle only structured data. The major drawback, right? Yes, can handle only structured data. Complexity increases, speed decreases, volume increases, right? If volume increases, speed decreases. No parallel processing, very less storage, right? GBs or TBs of data, right? Hmm. Now Hadoop advantages. Hadoop advantages, right? Yes. Hadoop advantages. First thing is unlimited data storage, right? Unlimited data storage. Unlimited storage is possible in Hadoop. Very high speed processing, very high speed processing, right? Very high speed processing. Yes. Unlimited storage, very high speed processing, can handle all varieties of data, can handle all varieties, can handle all varieties of data. It is an open source. It is an open source, no licensing required, open source, no licensing required, right? Unlimited storage, very high speed processing, can handle all varieties of data, open source, right? Commodity hardware. Commodity hardware, right? Unlimited storage, very high speed processing, right? Open source. Commodity hardware means can run on any hardware. It doesn't mean that you need to have very highly configured systems, right? Okay. Yahoo has conducted a test to check the speed of different databases. Yahoo has conducted a test to check the speed of different databases, right? Yes, Yahoo has taken a table. Yahoo has taken a table of 100 TB consisting of 1024 columns, 1024 columns, right? Yes. Time taken, okay, the task is sorting based on 16 columns, sorting based on 16 columns. Sorting not on single column, sorting based on 16 columns. Time taken by different. Time taken. First thing, Oracle, right? Oracle has taken nearly, yes, 3.5 days to process it. 3.5 days to process, right? MySQL, right? MySQL has taken nearly 6 days to process it. Oracle has taken 3.5 days. MySQL has taken nearly 6 days. And that specialized database, right, which is used for data warehouse purpose. Teradata, right? 4.5 hours. Another specialized database like Netija has taken nearly 3 hours, right? So yes, finally Hadoop. Hadoop has taken just 3.4 minutes. 3.4 minutes. Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata like 4.5 hours. Netija 3 hours. Hadoop has taken 3.4 minutes. The latest version of Hadoop has just taken 1.2 minutes. That is, Hadoop is proven in the market, right? Hadoop is proven in the market. So, processing point of view, it is proven, right? Most of this ETL, today if you see the ETL kinds of projects are getting migrated to Hadoop environment. Wherever you see like huge data, right? You see this Hadoop and PySpark are mostly used, right? So this is what the speed of Hadoop as compared with other technologies, very high because of this parallel processing. Because of this parallel processing, right? Yes. So, okay, in this course, I'll be discussing not only Hadoop. Hadoop is just 40% I'll be discussing, but 60% majority of this course I'll be discussing with PySpark. Spark with Python, right? So just I'll give a small introduction to this.
Before moving, I have a question.
Yes, go ahead.
So, this Hadoop is taking 3.4 or 1.2 minutes. Uh, what about the Azure? Because it's also using Spark and clusters. So, it is taking the same time or it's different? And how is different with Hadoop and Azure?
So, okay, Spark, and even in Azure, right? We have what Spark execution only. Even in Azure, right? We have what?
Yes.
Yes, we have what Spark. Spark is, observe here, as compared to this 100 times faster. 100 times faster than already Hadoop has got a great speed, but Spark, we talk about this PySpark, right? Is 100 times faster than Hadoop. So here, if I talk about this Spark, right, it is a distributed cluster computing framework. It's given by Apache Software Foundation for big data analysis, processing, and computation. Mainly, we see in-memory computation. storing within the memory level and processing within the memory level because of its very high speed. That is what with a very high rate of speed, right? That is 100 times faster than Hadoop in the case of memory, right? In the case of disk processing, 10 times faster. So PySpark, right? It is a Python API to use Spark. So it is a PySpark is one of the lightning fast technology that is designed for fast computation. It is mainly used for running distributed SQL, creating data pipelines, for ingesting data to the databases, for machine learning algorithms, working with graph algorithms, for data streams, right? So this, if you see, need what is the necessity for going for PySpark? Huge data is getting generated today, right? Everywhere you see like huge data. The data consists of hidden patterns, customer preferences, market trends, unknown corrections, right? So to extract some useful insights from that, from extracting some useful information from that, right? We need to have some efficient or flexible tools, right? To crack big data and gain benefit from it. So PySpark is such a kind, right? So Python and Spark is a very efficient way for the world of big. So combining Python and Spark will be the very efficient way for the world of big data. So that's why Apache Spark community came up with a tool called PySpark, right? Python API for using Spark. So mainly in most of this, even if you see mostly used in different environments. So even this PySpark for banking environment, for banks, financial environment, right? Where we see like batch processing, right? And also even in this e-commerce like Flipkart, Amazon, all this they use this PySpark for advertising, right? Fine. Even in this entertainment industry, right? Like Netflix is using Spark, and even in the tourism industry to provide advice to millions of customers, right? Yes. So as part of this course, what I'm going to discuss, right? So just check this course content, right? So first, starting with Hadoop, why Hadoop, needs for Hadoop, sources of this, advantages of Hadoop, right? And file system, there is a file system, right? There's some drawbacks with the databases. Despite of the drawbacks, still it doesn't go with any databases. It's going with a special kind of file system, Hadoop distributed file system. What is that? Name node, data node, secondary name node, metadata management, replications, fault tolerance, HDFS commands, right? MapReduce execution model. It's a for processing. We have got MapReduce execution model, right? Yes. And there is one more important component, Scoop, for importing and exporting data. Scoop, SQL plus Hadoop. The first two characters of this and last three characters of this forms a Scoop, right? SQL plus Hadoop. The first two characters of this and last three characters forms a Scoop. So importing or exporting, importing data from databases to Hadoop, the Scoop component, pulling data from different data sources and performing transformations, filterings, all different types of operations based on the business logic. And also exporting the process results, exporting back to the databases is done by a component called Scoop. Yarn, yet another resource negotiator. In the initial versions of Hadoop, right, there were some drawbacks which all got rectified in this from Hadoop 2 version onwards. We call it as Yarn, yet another resource negotiator. What are the various Yarn components, Yarn architecture? And as part of the course, I'll be discussing one NoSQL databases. SQL means structured, means schema required, but NoSQL means not only SQL, schemaless behavior, random access to get you right. One NoSQL database like HBase I'll be discussing. Apart from that, I'll be discussing one important component of Hadoop, Hive. Lot of discussion on this Hive. Only jobs like you have got jobs available only on Hive component if you have got good command on this, right? So I'll be discussing, spending some time on this Hive component, difference between HQL and SQL. Here also for Hive, we have got Hive query language similar to SQL language, right? Loading data from local files to Hive tables, loading data from HDFS to Hive tables, working with unstructured data, working with XML data, working with JSON data, working with URLs and weblog. Yes, UDF, UDAF, UDTF, user-defined functions, user-defined aggregated functions, user-defined that is tabular functions, right? Yes. Different performance tuning mechanism, like partitioning, saying static partitioning, multi-column partitioning, dynamic partitioning, and bucketing, indexing, combination of bucketing and indexing, combination of partitioning and indexing, right? For better, and have an HBase integration, no SQL integration, right? Next, I'll be discussing about PySpark, right? PySpark, PySpark session, PySpark context, parallelize, repartition, right? Broadcast variables, accumulators, PySpark RTD computations, right? PySpark core computing, groupings and aggregations, various actions and transformations, PySpark SQL data frame, right? Data frame, PySpark show, PySpark struct type, struct field, row class, select color with column, various built-in functionalities of this PySpark, PySpark SQL functions, aggregate functions, window functions, date and timestamp, PySpark built-in functions, when expr lit split concat overlay to timestamp date form. So in this way, many functions. PySpark external sources working with SQL statements, Spark and Hive integration, Spark with MySQL integration, transformations and actions, narrow and wide transformations, new columns, dropping off columns, renaming columns, handling nulls, window function, writing back to external sources, deployments mode, local mode, cluster mode, right? PySpark applications, stages and tasks, drivers and executor, deploying Spark applications to cluster and tuning, performance tuning, right? PySpark streaming concepts, integration with Kafka, and PySpark MLlib, right? This is what will be discussed as part of this Hadoop and PySpark. Apart from that, even people who doesn't have knowledge, who wants to prefer along with Python, right? So because PySpark, you need to have some command on this Python coding. Implementation goes in Python. So you'll be given brief knowledge on this Python also, right? Python basics, their installations, flavors, modes, interactive mode, batch mode, editors, variables, comments, type conversions, escape sequences, operators, IDEs, working with Anaconda distributions, Jupyter Notebook, Spider, PyCharm, Eclipse, flow control statements, looping statements, strings, indexing, slicing, string functions, string methods, string special characters, collections like lists, list indexing, list properties, list slicing, list functions, list methods, Python tuples, Python sets, Python dictionaries, functions in Python, right? Modules in Python, packages in Python, errors and exception handling, right? File handling in Python, object-oriented programming concepts in brief, regular expressions, database access, connecting with the database, right? Python data and time operating system module, right? Advanced concepts like iterator, generator, closures, decorators, working with CSV, XML, JSON files, working with workbooks, data analytics, working with data science, Pandas model in brief, NumPy model in brief, and plottings, generating graphs like Matplotlib model in brief, right? So this is what as part of this Hadoop, PySpark, and Python. So here, yes, I'll come back to your query, right? Gaurav. Yes. Okay. You should have seen, right? The PySpark in brief, in depth, it will be discussed along with Hadoop, right? Okay. Check with this. So here, the first thing is Hadoop. Secondly, PySpark, Spark with Python. Linux, Python. Okay, Python, right? Nearly okay. You need to have in-depth so by both Python core and advanced will be discussed. So for this Python core and advanced will be from Monday to Friday. It's like not like weekends. It will take time for if we go for weekends. Monday to Friday, you people will be attending any of my. I'll be just going with multiple Python batches. You can attend any of my Python batch. PySpark, right? Hadoop PySpark and this Linux. These are 12 weekends. It goes 12 weekends. 15,000 is the fee structure for this. One second. This Hadoop PySpark and this will be in the weekends. Saturday 2 hours and Sunday 2 hours will be right. From 7 to 9. The timing will be from 7 o'clock to 9 o'clock. This Hadoop PySpark and Linux will be discussed. And Python, this Python, you people will be attending any of my Python batch in the weekdays, right? From Monday to Friday. There is a 7 p.m. evening batch is available this Monday. Monday, there is a 7 p.m. batch is going. And if you anyone wants some morning, right? 5 a.m. there is a batch on this Thursday, coming Thursday. Check. So if you can see in the chart, right?
This, sorry to interrupt you. So this 7 p.m. is about to move to 8. Is it right?
Yes, yes.
Yeah, it's fine. Because 7, I have something. 8 is fine.
So 1 second. Those actually 7 p.m. means for the first 1 week it will be at 7 p.m. For the first 1 week it will be at 7 p.m. Later it starts at 8 p.m. up to the end of this course. Here also for the first 1 week it will be at 5 a.m. Later it will be starts at 6 a.m. For first 1 week 7 p.m. Later it starts at 8 p.m. up to the end of the course. First 1 week at 5 a.m. later. So if you want like Python, then just if you already so if you already know Python, if you doesn't want Python, right? The for this Hadoop, PySpark, and Linux, the fee structure is 12,000. With Python, it is 15,000, right? So it's an offer batch. So where you get these three technologies, Hadoop, PySpark, and Python. So in-depth knowledge on this Python you will be getting on Core and Advanced because for implementing PySpark, you need to have command under this Python programming and these things, right? And you will be getting the recorded what you are going to get, right? Yes. Recorded videos, right? Every session video, session videos, every session video you are going to get class notes, clear soft copy of the class notes. A WhatsApp group will be created for technical discussions. If you got any error, you can take the snap of it and just discuss. Interview questions at the last. Mostly asked interview questions in this, right? Fine. So you'll be getting the videos, notes, and a WhatsApp group and this. So I said, right, PySpark is a very demanding tool in today's industry, right? That's got the salary package also 1.5 times more than the other technologies. The same way they will be checking with your command in this technicals. So that's why if you see the course content, right, it will be like everything in brief, it will be discussed. So fine, just check this, right? Yeah. Some query was asked Gaurav Tomor, right? It's not complete PySpark course, right? That is entire PySpark close in Hadoop PySpark, right? Okay. MongoDB included in our course or not? MongoDB is not part of that. HBase is there. One NoSQL database, HBase I'm covering, right? Yes.
Uh, One more question. If someone wants this Python core and advanced plus PySpark instead of this Linux Hadoop,
Mm.
then we can do it. Because I have, but it's the requirement for data engineering from my side. There's Python and PySpark right now.
Python
Can I
and
do?
PySpark, right? There is a batch at if you want only like Hadoop, you're attending at 7 o'clock, right? But at 5 p.m. Today there was a demo, right, on PySpark. Today there was a demo on that PySpark at 5 p.m. today. Tomorrow you can attend at 5 p.m. There is a PySpark available, right?
Okay, okay. So I think PySpark is Python that two batch I will attend.
So yes, you can attend this Python and the PySpark. That is also fine. PySpark at 5 o'clock in the weekends. This is in the weekdays. You can attend. Not a fine.
Fine.
Okay,
This
fine.
5 p.m. For weekend, right?
5 p.m. Saturday and Sunday, right? So tomorrow you can attend at 5 p.m.
So that is 1 hour class or 2 hours?
So it will be 2 hours class, but tomorrow it's a demo session, right? So it will be for one and a half hour. Why it
Okay.
will be for 1.5 hour? It will be next week onwards will be for two hours.
And fees would be like of these
PySpark,
two.
PySpark and Python will be 10,000.
Okay, fine. Thank you.
Okay. Any other queries? Sir? Tomorrow also everyone can attend the session tomorrow at 7 p.m. using the same link, same time to see more on this, right? So today and tomorrow you can check it. Tomorrow I'll be just briefing you more on this, right? On this Hadoop and PySpark, more discussion, mostly on this Hadoop. Fine. So if I'm done with your queries, if there are no other queries, I will sign off for now. Meet you tomorrow at 7 p.m. More discussion on this and follow the same link, right? Thank you all for your time. Thank you. Meet you tomorrow. Bye. Is this course beneficial for a Java developer? Means yes, Gaurav Tomar, right? So is this course beneficial for Java developer? Means previously 10 years ago, when 10 or 12 years back, when Hadoop it was introduced to the market, right? Only Java developers used to update with Hadoop. But because of this huge program codings, huge programming, huge codings, right? Again, the people started migrating to other technologies. But again, the people like Apache Software Foundation, right? They have introduced different other components to decrease that coding, right? So now Java is not Java is not used. We are using other programming languages like Python here. So even as a Java developer, you have knowledge Python, right? We all these concepts will be little easier to understand. Even if you have got knowledge on Java, understanding this Python will be easier, right? Fine. But don't forget to install this Hadoop or Spark Java software compulsory required because previously, see, totally it was built on Java, right? Initially, right? Okay, fine. So we'll continue tomorrow at 7 o'clock, 7 p.m., same time on the same link, right? Yes.